All right, so we're going to learn about right triangle trigonometry, and that is if we have a right triangle, how are the angles and side lengths related to each other? So let me get my pen out. I like to write in blue. And so we're going to write some things here. I'm going to have an angle, and we're going to call that theta. And across from theta, I'm going to call this the opposite side. OPP for opposite, or sometimes I'll just do O. This is the opposite side because it's directly opposite from theta. Then I'm going to put the adjacent side, ADJ is how I'll abbreviate that, or just A. The adjacent side is a leg of the triangle, not the hypotenuse. A leg of the triangle that actually comes in and is one of the rays of your angle. And then I'm going to have my last side is the hypotenuse, and I'll just call that H. So these are the three sides of my triangle in reference to my angle theta. Now, if my angle theta was up here, this would be the opposite, and this would be adjacent, and hypotenuse would not change. And so we're going to define 6 trig functions as sine, cosine, tangent, cosecant, secant, and cotangent. You've seen sine, cosine, and tangent. I'm not sure you've seen cosecant, secant, and cotangent, but they're reciprocal functions of sine, cosine, and tangent. So we're going to fill in the ratio of these sides here. Now the sine of theta is going to always equal the opposite side divided by the hypotenuse. So if this is theta, the sine of theta is the opposite side divided by the hypotenuse. And the cosine of theta is the adjacent side divided by the hypotenuse. And the tangent of theta is the opposite side divided by the adjacent side. Now cosecant is the reciprocal of sine, so it's just this flippy-floppied. And my flippy-floppies, there we go. So that's hypotenuse over opposite. Secant is the reciprocal of cosine, and so that's going to be hypotenuse over adjacent. And cotangent is the reciprocal of tangent, so that's adjacent divided by the opposite side. So you're going to have to remember those, and something that you might have heard before in geometry is something called Sohcahtoa, and this is the sine of an angle is opposite over hypotenuse, and the cosine of an angle is adjacent over hypotenuse, and the tangent of an angle is opposite over adjacent. So that's one way to remember that: opposite over hypotenuse for sine, adjacent over hypotenuse for cosine, and opposite over adjacent for tangent. So you have to know those, and you also have to know cosecant, reciprocal of sine, secant, reciprocal of cosine, and cotangent is the reciprocal of tangent. So let's go work some problems. Okay, using triangle CED, find the values of the 6 trig functions for, by the way, this is supposed to be angle C and angle E. There was just a formatting issue, and that's why it's got the little parallelogram there. That's supposed to be angle C and angle E. So here we go. I'm going to write the sine, cosine, tangent, then cosecant, secant, and cotangent for angle C. Equals, equals, equals. Equals, equals, equals. So here we go. Where is angle C? Well, angle C is right here, and I want the sine of angle C. So the sine is going to be the opposite over the, I don't have the hypotenuse. That means I'm going to have to do the, what is that thing called? The a squared plus b squared equals c squared? That's right, the Pythagorean theorem. So I'm going to say 3 squared plus 6 squared has to equal c squared. So that's going to be 9 plus 36, that's 45, equals c squared. And the square root of 45 is going to be c. And what does that work out to be? Well, that's 3 square roots of 5. So this is 3 square roots of 5. Okay, so the sine of angle C is opposite over hypotenuse, and 3 was opposite from angle C, and the hypotenuse is across from a 90-degree angle, over 3 square roots of 5, which simplifies to 1 over the square root of 5. Cosine of angle C is the adjacent side over the hypotenuse, so that's 6 over 3 square roots of 5, which simplifies to 2 over the square root of 5. And the tangent of angle C is opposite over adjacent. That's 3 over 6, which simplifies to 1/2. Now the cosecant will be the sign flipped over, so that's the square root of 5 over 1. The secant would be the square root of 5 over 2, because that's a reciprocal of cosine, and the cotangent would be 2 over 1. You can do the same thing for E. I'm not going to write that down and waste our time here. Now here I've got a triangle, and I've got 4 6 square roots of 2, and I don't have this third side. So I'm going to, first of all, I'm going to make sure that really says 6 square roots of 2, because sometimes when I print it to my smart notebook, it doesn't print very pretty. Yes, that's 6 square roots of 2. Okay, just making sure. So here you just have to do your Pythagorean theorem to find the missing side. And I'm not going to work through that for you. You can do Pythagorean theorem and find your 6 missing trig values using Sohcahtoa. I don't want to waste our time on this. So let's come down and work some different problems. Use the diagram of, that's supposed to say triangle SRT, to find each side length. Alright, if the sine of angle S is 1/5, find SR. Now this gets a little tricky because this could have been simplified, but for now we're going to have to assume that the side opposite angle S was 1 and the hypotenuse was 5. Now it could have been 2 over 10, so this is a little bit misleading. We just know it reduced down to 1/5. So all we can do for now is we're going to say, well, that's a 1 and that's a 5. It could have been 2 to 10 or 3 to 15. We just know the ratio is 1 to 5. So find SR. So I'll just do the Pythagorean theorem. And so that's going to be 5 squared minus 1 squared for SR. That's a weird looking 5 there, Mr. G. So that's going to be 24. So this is the square root of 24, which is 2 square roots of 6. And again, I'm not this could be any ratio. They'd be in the same ratio, but this could have been 2 over 10 because this could have been simplified. So this is a little tricky. All right, let's do another example. Let me come erase these here. Let's work B. All right, if the tangent is 2/3 of angle T, so here's T, tangent is opposite over adjacent. So that the 2 would have been the opposite from T, and the 3 would have been the adjacent. I'm supposed to find ST. Again, it has to be in the ratio 2 to 3. It might be bigger or smaller than that. I don't know. Find ST is just the Pythagorean theorem. 2 squared plus 3 squared, that's going to be the square root of 13. So there's ST. You can work C out too there. Example 4. If cosecant of theta is 5. Now cosecant is the reciprocal of which trig function? Well, it's the reciprocal of sine. So I know that the sine of theta was 1/5. So you can think about this. The cosecant was hypotenuse over opposite, or you can go back to sine, opposite over hypotenuse. Either way, then I'm going to write little theta here. You can put theta anywhere you like. Here's theta. Cosecant is hypotenuse over opposite, so the hypotenuse is 5. The opposite side is 1, and I have to find the tangent of theta. So I'm going to go ahead and do my Pythagorean theorem backwards. 5 squared minus 1 squared. Well, that's going to be the square root of 24 is my missing side length, which is 2 square roots of 6. So the tangent of theta is opposite over adjacent, so that's going to be 1 over 2 square roots of 6. Okay, well that's pretty much it. You guys will be practicing Sohcahtoa stuff tomorrow in class, and I will see you then.